everyone, welcome to part 4 of chemical reactions and equations class 10. So if you have not watched the previous parts, make sure you go and check that. Now we're going to continue with decomposition reaction. So let's get continued. So let's get started with it. So first let us see one of an activity. So first let's take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note that the color of the ferrous sulfate crystals, the color of ferrous sulfate crystals is green in color, remember that. So heat the boiling tube over the flame on a burner and or a spirit lamp as shown. Observe the color of the crystals. So consider these are the ferrous sulfate crystals. Here is the boiling tube. So we are waiting for the gas to gently towards the nose. Do not keep it too near. So first thing that you can smell is the burning of the sulfur. You can smell the burning of sulfur in this particular experiment, and you can notice that the green color of the ferrous sulfate crystal will change to brown. So here this is ferrous sulfate. If we heat this, it will become ferrous oxide. So here this is ferrous oxide. This will become sulfate dioxide and sulfate trioxide. Ferrous sulfate is a solid, while sulfate dioxide and trioxide are gases. Now let's see what is written here. A single reactant breaks down to give simpler products. This decomposition reaction. So this is a decomposition reaction. So which means that a single reactant. So you can see that here this FeSO4, this is reacting. This is our reactant. This will only one reactant is there, but it breaks down into two or gives into many, how many ever products, however simpler products as possible. So a single reactant, there is just one reactant here. This will break down into and gives us simpler products. This is what is a decomposition reaction. This is opposite to a combination reaction, you can see. So ferrous sulfate crystals, which is FeSO4 7, they lose water when heated and the color of the crystals changes. Then decomposes to ferric oxide. We see, right? Ferrous sulfate, when they heat this, it will get into ferric oxide and the color of the crystal will also change. Then it decomposes to ferric oxide. So sulfur sulfur dioxide and sulfur trioxide, SO2 and SO3 will be created as one of the products. So ferric oxide is solid, while SO2 and SO3 are gases. I told, right? Sulfate dioxide and sulfur trioxide are gases. These are all very important parts of the chapter, so make sure you are thorough with them. So now we are going to see about the decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. So that is decomposition of calcium carbonate to calcium oxide and carbon dioxide. So first of all, what they are trying to tell here is this calcium carbonate is there. This will be divided into calcium oxide and carbon dioxide on heating. So the process would be that calcium carbonate is there. This, if we by heating them, we will get calcium oxide and carbon dioxide. So this is an important decomposition which is used in many industries. So calcium oxide is called as quicklime. We saw that, right? The heating of the walls and all. So not heating of the walls, the heating temperature of the chemical change. Quicklime will, the slaked lime we saw in the previous videos and all. So it has many uses. One of its manufacture of cement. Cement is also used in cement or whitewashing the walls and all. So while decomposition reaction is carried out by heating, it is called as thermal decomposition. What is it called as? Thermal decomposition. When decomposition reaction is carried out by the process of heating, it is known as thermal decomposition. Alright. So you see limestone is there. So this limestone, when we heat them together, we'll get carbon dioxide as well as quicklime. So calcium carbonate is there. They are doing it, we'll get CaO. This is how we get quicklime, and this will then further will be done in the combination reaction. Then only we'll get all the stuff. So let's not get confused or get too much into the previous learn things. Let's just continue. So now we have heating of lead nitrate and emission of nitrogen oxide. dioxide, sorry. So you will observe the emission of, okay, let's see. So first you're taking 2 grams of lead nitrate powder in boiling tube. So there is a boiling tube, you're taking 2 grams of lead nitrate powder, and in that you're holding the boiling tube with a pair of tongs, and you hold it over the heat or a flame. You can see that there is this lead nitrate in the boiling tube, and here is the burner. So you can see that boiling, there are some very like orange or brown color fumes which are coming out of this. This is an emission of nitrogen dioxide, okay, NO2, nitrogen dioxide. This reaction takes place is, so here you can see that lead nitrate, when we heat it, we'll get lead oxide, and here what will happen is that nitrogen dioxide will be emitted, and with and oxygen also will be emitted. How can we see that oxygen is also emitted? We can take a incense stick, and if we keep it inside, not too much inside, if we keep it near the fumes, you can see that the incense stick will light up. That is how we can see the presence of oxygen in this particular experiment, where the lead nitrate and lead oxide. When we heat lead nitrate, that is what would happen. We'll get lead oxide, and that lead oxide will even have nitrogen dioxide, and we'll even have oxygen. So this is a very important experiment. Learn this. At least you just have to memorize it. There's no other way. Coming to a very important activity. So first you're taking a plastic mug. You're drilling 2 holes in the base of, and first let me just explain this in my own words. So first of all, there are 2 of these granites here, and there is a little cell in here. If you can see, there will be a little cell in here, and these cell will be connected. Like here, there is an anode is here, cathode is here. Anode, first I am telling you, anode is an positively charged terminal, while cathode is a negative charged terminal. So what will happen is that and this is graphite rod, and here there is water, and there is dilute sulfuric acid also you can add. So you can see that there is this test tube which is inverted. So you can see that there is this battery also connected to them, which is the anode and cathode and all that. Okay, so now what would happen is that in this water, this H2O would then converted into H plus OH. So H is positive while OH is negative. So positive and negative terminal will get together, and negative and positive terminal will get together. What do I mean by this? That is, hydrogen will go towards cathode. That is positive. This is hydrogen, right? Hydrogen will go towards cathode. Okay, hydrogen will go towards cathode, while oxygen will go towards anode. And more of hydrogen is produced because the composition of hydrogen and oxygen in H2O is hydrogen is more, and oxygen gas will go towards anode, and there will be less oxygen gas emitted. This is oxygen, you can see, right? So again I am telling, cathode is a negative terminal. Because cathode is negative, hydrogen gas will be emitted here, and there will be more of hydrogen gas and less of oxygen gas near the anode. Okay, now we are in the activity 1.8. Here if we take 2 grams of silver chloride in a china dish like this, and then this is china dish and this is silver chloride, and if we pass sunlight like through it, what will happen is that what will the color be after you put sunlight? So when we place the china dish in the sunlight for some time, we observe that the silver chloride, silver chloride will change the color of gray. Okay, so we'll see that the silver chloride turns gray in sunlight, and this is due to the decomposition of silver chloride into silver and chloride by light. So there is silver chloride, and this will turn gray in sunlight due to the decomposition. That is, the silver chloride will turn into silver and chloride by the light. So when an decomposition reaction that takes place in the presence of light is known as a photo decomposition reaction. And just like silver chloride, the silver bromide will also behave in the same way. You can see that this formula. So in the above reactions are used black and white photography. So in the black and white photography, these silver chloride and silver bromide are used. So what form of energy is causing these decomposition reactions? If they ask, decomposition reactions require energy. We saw that it can be heat energy, light energy, or even electricity energy. So it's the breaking down for reactants. So this is the so now we are going to see another definition. So reactions in which energy is absorbed are known as, that is, heat energy will be absorbed in this kind of reaction, but in these kind of reactions are endothermic reactions, while heat energy is absorbed. Exothermic reactions are when heat energy is released. These are the answers for these questions. Make sure you go through them. So thank you for watching. We'll see displacement reaction in the next video. Go and make sure you watch the next video and hope you enjoy.